Okay, now we want to solve some practice questions from the textbook, and you can also think this as somehow a way to review what we studied in this chapter. Let's start with 4.1. We want to calculate the accumulated value at the end of 8 years of payments 4,000 a year, which are paid monthly at the start of each month. Uh, for all those type of questions, there are two different ways. One is you do it when you draw the timeline. Let me do it. Then we illustrate. First, I will show you what um, we have studied so far from this chapter is, well, when we draw the timeline, you still use the unit to be 1 year. So this is 8. Okay, so now the payments are made monthly at the start of each month. So you will have payment down here, you have a payment down here, payment down here, goes all the way to here. So what you have down here would be 12 payments, right? So there are 12 months each year, meaning you're going to see 12 payments. All of them are at the beginning of each year. The total is 4,000. So you would know each payment would be 4,000 divided by 12, right? And you continue the same thing for the other 7 years. So here, 1 period equals 1 year. That is something we have been doing for pretty much most of this course so far, right? We choose 1 period to be 1 year. But of course, that does not need to be the case. So from here, we can somehow analyze, because this is a piecely payment, right? And it's annuity due. So what we want is of course, we also know the interest rate, which is 9%. So using the notation we introduced, that would be from section 4.5, I believe. 4.5 is annuity due payable monthly. Exactly, that's it. But one thing we need to know for the notation is, in that case, right? Remember, the payment is always 1 over p for each payment. Right now, what we have is 4,000 over 12. P is 12 in this case. So we have a little factoring issue, right? You need to take care of. So what we have would be 4,000 times by annuity due. So, and here we have upper P, but we have exactly 12 payments each year, and we have 8 years. That I is 9%. So from here you can go with 4,000 times 1 plus 1 minus 1 plus I to negative n divided by, because this is an annuity due and it's piecely, so it's d upper p. So from here you just need to figure out the dp, but this is not the method I like, because it requires you to memorize somehow everything from here, right? You need to know the payment is exactly piecely, and it's not what I prefer. So now I do what I would like to solve this question is, I always convert the unit period to the one that coincides with the question. In this case, the payments are made monthly. So in the next graph, 1 unit equals 1 month. Okay, previously is 1 year. So now here 1 means 1 month, and the payment would be 4,000 divided by 2. In the second month, the payment is the same, goes on and on. There are 8 months, not 8 months, 8 years, meaning I will have 96 payments. The first one is at the beginning, meaning my last payment will be paid at 95 or 95th month, okay, over the entire 8 years. So now what I want is 4,000 divided by 12. So each payment, because now I'm looking at each payment, this is standard level annuity due. So it is a level annuity due for 96 periods. And I just need to know the effective interest rate per period. So in this case, it would be monthly interest rate. It will be I upper 12 divided by 12 in notation. And in computation, it will be the effective interest rate. Take a fraction power, 1 over 12. 1 is 1 year, so 1 divided by 12 is 1 month. So this gives me the accumulation factor for 1 month. Minus 1 would be due the effective interest rate per month. So just need to solve everything. And from here, you know what is J, right? And then you plug in this formula. Right? So this is an annuity. Oh no, so it's not A, it's S. We wanted we actually want the accumulated value. So I have to collect this into S. The accumulated value would be 1 plus, okay, it should be J, because J is now the effective interest rate. For the number would be 96 instead of 8, because now the unit is 1 month and I have a total of 96 months. And because this is an annuity due, so I'm supposed to put D for the denominator, and D in this case will be J over 1 plus J. Okay, and from there you can easily solve. So this is what I prefer, because in fact I don't even like to memorize this formula, because the way I usually solve this is I want future value, right? So I just convert each one to the end point. So for the last payment, I will need to accumulate by 1 year, and the second to the last, I need to accumulate by 2 years. The last one is 96. So from here, I can directly apply my my knowledge on geometric series. It's 1 minus the ratio. So it's 1 minus 1 plus J. So it should be negative J. So put J, reserve a negative sign. So here we also switch the order. That is 96. Well, you see, this is exactly what I have done here. Right? It's a simple geometric series. You don't necessarily need to memorize that from here. You know, for the actual exam, you don't need to write this step. Right? This step should be in your brain. You can easily process this information and then directly write down everything. Okay. That's 4.1. Let's do the next odd question. 4.3. Determine the present value of payments of 500 at the end of each year for the next 20 years. The nominal interest rate is 5% convertibly monthly. Okay, this is actually an easy question, because we have $500 at the end of each year for 20 years. So this is a standard annuity immediate, and we want to know the present value. So this time I'm correct in writing A. So this is what we want. The only question is we don't know I, but we do know I upper 12 is 5%. That means it's convertible monthly. So P is 12. So from there, it's easy to get I. I would be 1 plus I upper 12 divided by 12. And then I need to compound for 12 months, minus 1. I can get I. Once I get I, this should be easy by now. Next, 4.5. Determine the annual effective interest rate that corresponds to a nominal rate of discount of 6% convertible quarterly. So we know the nominal discount is 6%, compounded, convertible quarterly. So that's the upper 4 is 6%. The question asks you what would be the annual effective interest rate. So of course there are formulas you can apply, right? So 1 minus the upper 4 divided by 4. This is the discount factor for 1 quarter. And we raise to the power of -4, meaning we will get the accumulating factor for 1 year. So that's exactly 1 plus I. So from there, you can easily solve. I can even ask you, what would be the nominal interest rate, convertible monthly, right? Then once you get this, you will need to keep writing, right? So from here, I go from D4 to I12. So that's please complete all the details. The solutions are given in the back of the textbook. You can actually access. 4.7. Find the accumulated value. So it's S at time 15 years of payments, 455 a time, and so on. So it's equal payment. So that's good. One thing we don't have is the interest rate. So this is very similar to the question we just solved. So this is level annuity, and it starts at time 0, so it's at the beginning of each period. So that means we will have double dot for our S. It's the accumulated value of annuity due. How many payments? I have 15 years, but what I don't know is the effective interest rate. But I'm given the discount rate is 3.5%, convertible monthly. So we are doing things repeatedly. So from here, 1 plus I equals 1 minus D upper 12 divided by 12. And then obviously I need to raise power to -12. So once I know I, this is easy, right? So once I know I, this becomes 455 times 1 plus I to the number of n minus 1 divided by D. D is I divided by 1 plus I. Okay. Go on to the next odd question, 4.9. Money is invested, money is received at a rate of $6,088 per year. Found the accumulated value at time 16 years of the money received, given that payments are received at the end of every other year. That means you receive one payment every 2 years. The nominal interest rate is 10%, convertible every 6 months. So there's actually a mismatch. Okay. Again, there are two different ways of solving this question, just like the first one we did. So I first show you what I prefer. We have 16 years in total. We get one payment every 2 years. So one period in this case would be 2 years. So basically, the unit period should match the payment frequency. So if it's paid every other year, the unit period would be 2 years. So it will be 1, 2, all the way to 8. We have a total of 16 years. That gives you 8 periods. One period has 2 years. Then we need to know the payment of each period. It would be 6,880 times by 2, because one unit has 2 years, and 6,880 is the payment rate per year. Here I want 2 years, so I double. What I want to know the future value. So leave out this factor. The money are received at the end of each period. So which means I'm looking for a standard annuity immediate, and I want to know its accumulated value at the end of 8 periods. So J would be the effective interest rate for one period. In this case, it's actually for 2 years. Right? I is the annual effective interest rate. Okay, that means it would be 1 plus I upper 6, upper 2, not upper 6. Right? Then you should be able to get J. Once you get to J, this guy is easy. It is just 1 plus J to the power of 8 minus 1 divided by J. That's because we have a standard annuity immediate, we divide by J, divided by the effective interest rate, right? So if you have annuity due, you are going to divide by the discount rate. So it's, for instance, previously we divided by D, right? So that's 4.9. What's next? Find the AV at time 20 of 50,000 a year paid at the start of every half year. By the way, this is just a one way. Okay, you can also use the notation of I half. Right, this is the nominal interest rate quoted on a yearly basis for a 2-year period. Okay, you can do that as well if you want. So this is only one method. This is the second method. But I always do the first method, at least that works well for me. Next one. Okay, the payment frequency now it's half a year. So one period right now equals 6 months. At the end of 20 years, so 20 years means there are 40 periods. Okay, the payments are 50K a year paid at the beginning. So, which means here I receive 25K. Here I receive 25K. Well, that would give me $50,000 a year, right? And it's always the beginning, so it's 0, 1 instead of 1, 2. Continue until the last one. I still want the accumulated value. It seems that all the odd questions ask us to do the accumulated value. So the next one, probably we should switch to an even question to do the present value. But anyway, I have equal payment, 25,000. I want to know the accumulated value. So this is S double dot because it's a due. The total number of payments is 40. Then I will need to know the effective interest rate per period or every 6 months. The interest rate we have from the question is 6% convertible monthly. So what I have is actually I upper 12 is 6% convertible monthly, 4.11. So 6%. So that means what I'm going to do for the J would be 1 plus J. This is the AV for 6 months. So this is 1 month. So obviously I need to raise power to 6. Well, if you feel uncomfortable, you can square on the left-hand side and put 12 to the right-hand side if you want. Okay. From here, you should be able to get J, right? Once we know J, everything it's more than obvious because -1 divided by the corresponding discount rate. So it's J over 1 plus J. This is again method 1. This method 2 as well, right? So method 2 will involve 1 year I receive this amount, so I should put it in front, 50,000 instead of 25. I still look for the accumulated value for a due, but now it's piecely, right? Piecely, and here P is 2. It's paid 2 times a year. And then here angle N would be the number of years. So instead of 20, instead of 40, I will have to put 20 down here. And the corresponding interest rate would be I, the annual effective interest rate, instead of J. J is the effective interest rate for 6 months. Okay, next, let's do a even question. Found the PV of payments 5 now, 10 in 6 months, 15 in 1 year. So we easily see the payment frequency is 6 months. $5 now, 10 in 6 months, 15 in 1 year, and so on until the end of 6 years. 6 years means it's 12 because it's a due. So the last payment is at 1 period equals 6 months. Okay, so here that is the payment stream, right? So obviously this is a due, and I can easily factor out $5. Then it becomes 1, 2, 3, 4, all the way to 12. So this is an increasing annuity due for 12 periods at effective interest rate J, which is to be calculated. Here I have discount rate convertible every 6 months. So it's D upper 2 is 12%. So from there I have 1 minus D upper 2 divided by 2 raised the power to -1. Then I get the accumulation for 6 months. That is exactly 1 plus J. So I should be able to get J. Okay, once I know that, I plug in the formula for increasing annuity due minus 12 times the corresponding using discounting using J. Okay, and obviously I need to divide by the discount factor. So actually this is nice because it matches the discount frequency of the given one, which is 2, right? Here we want the J is for 6 months. This is exactly for 6 months. Okay, and obviously we know everything. We know this. We know this. We just don't know the this guy annuity due. This is the present value, so it's 1 minus 1 plus J to -12. Okay, and divided by the corresponding discount rate. Now, if you want, you can even do J over 1 plus J, but you would know this is the same as 6%. So then you plug in, you will be able to get the answer. Again, this is method 1. What would be method 2? In method 2, what we have is we will need to put everything in 1 year. So here we have 5%. We will need to write everything in a nice way. What is $5? Because remember what do we have for the, okay, so here is the call. In the textbook for the standard notation is 1 over P squared, 2 over P squared, 3 over P squared, etc. Right? This is how the sequence of payments grows, right? So this is a P3 increasing. But here we have 5, 10, 15. Obviously, that does not fit this rule, right? So P in this case is 2 because I have 2 payments a year. So 1 over P squared would be 1 over 4. So how can I make 5 1 over 4? It will be 20 times y over 4. That's $5, right? And then the next payment is 10. That would be 20 times 2 over 4, right? Etc. So obviously 20 has to be factored out. Then I can use the notation we introduced. I upper 2, and it's actually annuity due. So I need to put double dots, right? So this is a piecely increasing and the piecely payment. Okay, and then here n would be the number of years. Here I have 6 years. Okay, this is the notation from the second method. If you want ever to use from this chapter. So basically, I don't think I will require you to apply either method. It's up to you to use either one or two. Again, my preference is to use one. But for the second one, I would like you to understand the notation. Understand the notation, okay? Not the formula. Okay, notation meaning once I write this down, I would know my first payment is 1 over p, second is 2 over p, etc. Goes on for n years. This 6 would be the number of years, and in each year I will have 2 payments. Okay, this 2 means for the 2 payments in each year they are increasing. So let's do one more to finish this exercise session. The last one. Marini invests X now in order to receive 5 in 2 months, 10 in 6 months, 15 in 6 months, 10 in 4 months, meaning the payment frequency is 2 months. So she will invest this amount X. In the first period, she will get $5. In the second, she received 10. Third, 15 goes on for 10 years. Okay, 10 years means it's going to be 60 because 1 period equals 2 months, right? So 1 year would give you 6 periods. So a total of 10 years will give you 60 periods. So that's why the last one is 60. This is also where I get my last payment. Right? I know it's 300 because 5 is 5 times 1, 10 is 5 times 2, 15 is 5 times 3. Then the last one would be 5 times 60. So it's $300. Okay. I want to know the present value. So let's factor out this 5. Then it becomes 1, 2, 3, all the way to 60. This is the increasing annuity immediate for 60 periods. J is the effective interest rate for 1 period. So means J would be I6 over 6 in notation. In computation, it would be, we know I is 8%. So it's 1 plus I raised to the power of 1 over 6 minus 1. Okay, what is the number? I get this is about 1.2909. So once we know this, we can keep writing. Okay, a standard annuity, a standard increasing annuity minus n times v, 1 minus 1 plus j to negative 1, then 60. Okay, this is a standard, or because this is an immediate, so you divide by the effective interest rate. So you should be able to finish from here. So well, the only thing that remains to be calculated is this annuity due. This will be 1 minus 1 plus j to negative 30 divided by the corresponding rate of discount, right? By the way, if you calculate, this should be about 62,1207. Okay, so here, please complete. You plug everything in, you should be able to get the result. Again, this is the first method. You can also apply our notation. then what you need to factor out is to get 1 over p squared. So in this case, so 1 over p squared is actually 36. So obviously we need 5 times 36 to be leaved outside, and then we will have 1 over 36 for the first payment. Is increasing monthly, not monthly, every 2 months. And it's A because it's the annuity immediate P3 payment for 10 years. Right, this is the notation. Okay, of course, I already derived the formula. If you rely on formula, you should use this to practice. Again, 1 seems to be a better choice. Let me conclude here, and feel free to ask any other questions if you may have.